Okay, welcome back. So, we're going to go through some examples. Here they are, one by one. The first example, I see I have a fraction. The degree of the polynomial on the top is 0 because there's no x's or anything. Degree on the bottom is 2. Okay, so the degree on the top is less than the degree on the bottom. That's good. So I can go ahead and express it. But first of all, I need to factorize the denominator. So to find the factors, I look at the first number and the last number, 1 and 2, and I say 1 times 2, the coefficient of the quadratic term. We understand here that we have 1 times x squared, so that's where we get the 1 from, and it's 1 times 2 makes 2. And then we look at the middle number, which is 3, and I say I want two numbers that multiply together to give 2 and add together to give 3. Well, 1 times 2 is 2, and 1 plus 2 is 3. Those are my two numbers. So the factors I have are x plus 1 times x plus 2. And now I can write my fraction as 3 over the product of factors. And that is equal to some constant over x plus 1 plus some constant over x plus 2. And then I multiply everything. I'm going to find what the constants are. I multiply everything by x plus 1 times x plus 2. So on the right, if I multiply by x plus 1, it cancels that out. Multiply by x plus 2, it cancels that out. And we have just 3. And over here, multiply by x plus 1, cancels it out. And then I multiply by x plus 2, but that x plus 2 doesn't get cancelled out. It stays there like c1 times x plus 2. There we are. Then over here, I multiply by x plus 1 and see it can't get cancelled out. So I have c2 times x plus 1. Then I multiply by x plus 2 and it gets cancelled out. So nothing happens there. Right, so what I'm going to do is on the left hand side I have just 3. And I understand that's like saying 0 times x plus 3. Because I have degree 1 polynomials here, it's important to stick this here. 0 times x plus 3. And then I expand these brackets. I have c1 times x plus c1 times 2, so 2c1. And then I expand over here. I have c2 times x plus c2 times 1, which we understand is just c2. And now I'm going to group my x terms together. So I have x times c1 plus x times c2. That's like saying c1 plus c2 times x, plus 2 times c1 plus c2. Now, on the left and the right-hand side, I have polynomials. They have first-degree terms and constant terms, and those two degrees are separate from each other. So, the x stuff and the constant stuff, those things are equal. So I'll do the x stuff first. On the left-hand side, we have 0 times x. On the right-hand side, we have c1 plus c2 times x. I can go ahead and divide both sides by x, which just gets rid of it there and gets rid of it there. So I'm saying c1 plus c2 equals 0. That's my first equation. It's an equation with two unknowns. Now, I look at my constant terms. I have 3 equals 2c1 plus c2. Okay, well now that's my second equation. I have two equations with two unknowns. It is simultaneous equations. What I do is over here I say if c1 plus c2 equals 0, then c1 and c2 must basically be the same number but opposite signs. So when I add them together, they cancel out. If I subtract c2 from both sides, I get negative c2 equals c1. You kind of see the numbers are opposite signs. So if c1 was 3, then c2 would be negative 3, or vice versa. So I can take this info and put it in here. So everywhere I see c1, I'm going to swap it out for negative c2. So 3 equals, 2 times c1, that's negative 2 times c2, plus c2. Negative 2 times c2 plus c2 makes negative 1 times c2. So in this case, c2 is negative 3, and then c1 would be the opposite of that, positive 3. So when I write this equation, another way to write it is, let's see, c1, which is 3, over x plus 1, plus c2, which is negative 3, over x plus 2. All of that with respect to x. And now I'm gonna, what you can do when you have several things adding up together, taking the integral of them, is you can just split those integrals up, and that's equal to the integral of 3 over x plus 1 with respect to x, plus the integral of negative 3 over x plus 2 with respect to x. And now this looks like a substitution problem, because I can take the 3 and the negative 3 out the front, and this is like 3 times 1 over x plus 1 with respect to x, plus negative 3 times 1 over x plus 2 with respect to x. And we know that the integral of 1 over x is ln x. We haven't got 1 over x, we've got 1 over x plus 1. So we just do the same thing that we were doing in the u substitution. That is, we recognize that we take the integral as if it were x, and then just divide by the derivative of the inside of the bracket. Derivative of this is 1, so we divide by 1, which does nothing. And it's the same thing over here for the second one. But we've got to always add a c, add a constant. Okay. Well, wasn't that fun? Let's do the next one. I'll make some